The question is about a simple purchase scrap. The number of teeth on pinion is 25 and the spur wheel is 250. So number of teeth on pinion, that is given by T1, which is equal to 25, and T2 is equal to 250. The radius of the drum and handle, that is the radius of the drum. On the drum side, we will be seeing the load that is being lifted. So a radius of the drum, that is small r, equal to 150 mm, and the length of the handle onto which the effort is given as input, L, is equal to 300 mm. Efficiency of the machine is how much? Effect of friction, that is frictional effort, and if an effort of 20 Newton can lift the load. So effort is given as 20 newtons and load is 360 newtons. So now first is that you can calculate velocity ratio. So velocity ratio is given by VR equal to, first is that we divide the effort dimension or effort wheel, that is L, divided by R, it would be the radius of the drum or where the load is being lifted, and this needs to be multiplied with T2 by T1. See, remember here the concept is on the handle side where the effort is being applied, it is compounded, or on the same shaft there is a pinion mounted whose teeth is 25, and next is the load which is being lifted has the gear whose number of teeth is 250 and the radius of the drum is 150. So remember that the length of the handle is directly proportional to number of teeth. So if L, that is length of the handle, is in the numerator on the same handle or the shaft onto which the handle is mounted, and the teeth would be reflected, the teeth associated with the same shaft will be reflected in the denominator. That logic you have to understand. So as it was previously indicated in the derivation as well, so you can generalize or you can quickly memorize this logic. That is, length, if the length of the handle is in the numerator, the corresponding gear which is mounted on the same shaft which is carrying handle has to be reflected in the denominator. Same way, that logic also works for even the shaft which is carrying the drum as well as the gear. Gear means the bigger one having T2 teeth, which is 250. So L here it is 300 into 250 divided by R, here it is 150 into 25 it is. So 25 ones and 25 tens, and this would be 150 ones and this is 150 twos. So velocity ratio comes out to be as 20, and mechanical advantage, which is equal to W by P, which is equal to 360 divided by 20, which is 18. And efficiency in this case would be mechanical advantage divided by velocity ratio. So mechanical advantage is 18 divided by 20. This will be equal to 0.9. 0.9 or 90% would be the efficiency. Next is effort lost in friction that needs to be computed. So effort lost in frictional or frictional effort is equal to actual effort minus ideal it is. So actual minus ideal is W by velocity ratio. So actual effort, that is 220 minus W is 360 divided by 20 it is. So this is two ones and two 18s. So 20 minus 18, which is 2 newtons. Same way, the load lost in friction, that is friction load, which is equal to ideal load minus actual load it is. So ideal load is velocity ratio into, so frictional load, that is given by ideal load minus actual load, that is velocity ratio into actual effort minus actual load it is. So velocity ratio is 20 into effort that has been imposed is also 20 minus 360. So this is equal to 400 minus 360, which is 40 newtons.